Ancient builders created structures that modern engineering still cannot fully explain. By the end of this journey, you will gain a completely new perspective on human history and its lost technological marvels. We will uncover why a 2,000-year-old device is considered the world's first computer and how massive stones were moved with impossible precision. These 23 forgotten engineering puzzles defy everything we thought we knew about the past. What does it mean when history's greatest achievements remain a mystery to their successors, sponge divers, working off the coast of a tiny Greek island in 1900? One had no idea they were about to pull a ghost from the depths. Their prize, recovered from an ancient Roman shipwreck, was little more than a heavily corroded lump of bronze and wood, seemingly unremarkable amidst the statues and pottery. For decades, it sat in a museum storage room, a forgotten curiosity. But then, researchers took a closer look. Inside that calcified lump was an intricate clockwork of interlocking bronze gears, a technological artifact so advanced it should not have existed for another 1,000 years. This is the Antikythera Mechanism, a device often called the world's first analog computer. Crafted around 100 years before the Common Era, its purpose was staggering. By turning a hand crank, the user could predict the movements of the sun, the moon, and the known planets. It forecast lunar and solar eclipses with remarkable accuracy and even accounted for the irregular orbit of the moon. For ancient sailors, philosophers, and kings, this was a window into the future of the heavens. Modern experts like Dr. Tony Freeth used advanced X-ray technology to peer inside the encrusted mechanism, revealing previously hidden inscriptions and a complexity that rivals the finest medieval clockwork. The most shocking discovery was a set of differential gears, a sophisticated arrangement believed to have been invented in the 16th century. This single component rewrites the timeline of engineering. How could such profound knowledge, this mastery of mathematics and precision mechanics, simply vanish? The Antikythera Mechanism stands as a solitary relic of a technological peak that was followed by a silence lasting over a millennium. Its very existence forces us to ask a difficult question. What other engineering marvels were lost in the shadows between the ancient world and our own? That solitary ghost from the ancient world was not entirely alone. While the Antikythera Mechanism lay hidden beneath the Mediterranean waves, another technological phantom was quietly unearthed from the desert sands of Iraq. In 1938, a German museum director named Wilhelm Koenig was cataloging artifacts in the basement of the Baghdad Museum when he made a perplexing discovery. He found a collection of simple terracotta pots, each about the size of a man's fist. They seemed unremarkable at first, but inside each one was a carefully rolled copper cylinder, and suspended within that cylinder was an iron rod. The entire assembly was sealed at the top with an asphalt plug. What struck Koenig was the condition of the iron rods. They were heavily corroded, but only on one side, as if they had been eaten away by an acidic substance. He proposed a theory so radical it was immediately dismissed by many. He suggested these 2,000-year-old pots were, in fact, primitive electric batteries. The design is deceptively simple. If you were to fill one of these pots with an acidic electrolyte, something as common as vinegar or grape juice, a chemical reaction would occur. The acidic liquid would interact with the two different metals, the copper and the iron, creating a small but measurable flow of electricity. It is the exact same principle behind the modern galvanic cell. Experiments by researchers like Dr. Arne Egebrecht proved this was not just a theory. He created replicas of the artifacts and found they could produce over 1 volt of electricity. It is not a lot of power, but it is consistent and real. So what would an ancient Mesopotamian artisan do with a steady, low-level electric current? One compelling possibility is electroplating. You could use the electricity to deposit a thin, beautiful layer of gold or silver onto a less valuable metal object, like a statue or a piece of jewelry. This would create the appearance of a solid, precious metal object at a fraction of the cost. Other theories suggest these batteries could have been used for medical purposes, perhaps for a form of electrotherapy, using a mild, tingling sensation to treat pain, a practice that would not be rediscovered in the West for centuries. The controversy, of course, is fierce. Many archaeologists maintain these vessels were simply storage containers for sacred scrolls, and the corrosion is just a coincidence of time. Yet the asphalt seal, which is an excellent insulator, and the specific choice of two different metals point toward a more sophisticated purpose. If these were indeed batteries, they represent a spark of electrical knowledge that flickered and died long before it could catch fire. They challenge the very backbone of our technological timelines, forcing us to wonder if we have underestimated the innovative spirit of the ancient world. This electrical enigma, a silent power source waiting in a clay pot, connects to an even more immense mystery, one carved from stone on a scale that seems to defy human labor. Hundreds of these strange, hollow objects have been unearthed across Europe, from the ruins of Roman Britain to the outposts of the Danube. They are the Roman dodecahedrons, palm-sized artifacts cast in bronze with a geometric perfection that feels both ancient and eerily modern. Each one has 12 identical pentagonal faces, each face pierced by a circular hole of a different diameter, and at every corner sits a small, solid knob. They are beautiful, precise, and utterly baffling. Ranging from the 2nd to the 4th century of the Common Era, these objects have been found in the hundreds, suggesting they were not rare curiosities but items of some common, understood purpose. Yet in all the vast records left by the meticulous Romans, there is not a single word, not one drawing or inscription that describes what they were for. This silence is as profound as the objects themselves. The theories are as varied as they are creative. Perhaps they were ornate candlestick holders with a wax taper inserted into each hole. Maybe they were decorative knobs for the staffs of high-ranking officials. Some suggest they were tools for knitting gloves, used to gauge different finger sizes, while others propose they were religious relics, symbolic representations of the universe or used for divination. Experimental archaeologists like Dr. Gunther Fischer have explored more technical applications. His research shows that when a dodecahedron is held up and sighted through its various holes, it can be used to calculate distances and angles, potentially functioning as a sophisticated surveying tool for Roman military engineers. The different hole sizes could correlate to specific measurements, allowing for quick calculations in the field. Yet for every theory, a problem arises. If they were surveying tools, why are they often found far from military sites, in civilian homes and even graves? If they were for knitting, why are they made from valuable bronze and crafted with such exacting, durable precision? The very standardization of their design points to a specific, widely understood function, a function that has now been completely erased from history. Why would a civilization that documented so much leave no clue about an object they made in such numbers? The dodecahedron is a locked door with no surviving key, a perfect geometric form that holds a shapeless, frustrating secret. It represents a different kind of loss than the Antikythera Mechanism, not a pinnacle of high technology, but a fragment of everyday knowledge that has simply slipped through the cracks of time. This mystery of a common object with a forgotten purpose stands in stark contrast to another Roman achievement, one of sheer, incomprehensible scale. While the Romans left behind small geometric puzzles, they also mastered engineering on a colossal scale, creating materials that our modern world struggles to duplicate. Walk along the coast of Italy today and you can see the crumbling remains of modern concrete piers, their steel reinforcements rusting away after just a few decades of exposure to the sea. Then look out at the ancient Roman harbor of Portus, its breakwaters still standing strong and intact after 2,000 years submerged in the Mediterranean. This is not a matter of luck, it is a testament to a lost technological secret, the recipe for Roman maritime concrete. Modern concrete, for all its strength, is ultimately no match for seawater, which slowly penetrates and degrades it from within. The Roman version, incredibly, does the opposite. It actually gets stronger. For centuries, the formula was a complete mystery, a ghost of knowledge that vanished with the empire's fall. Then, a team of geologists from the University of Utah began to analyze the ancient harbor structures, drilling out core samples to peer into their atomic heart. What they found was astonishing. The Romans were not just mixing sand and gravel. Their concrete was a sophisticated blend of volcanic ash, lime, and a surprising key ingredient, seawater itself. They would combine these materials to trigger a chemical reaction that modern science had never observed in such an ancient context. The secret lies in a rare mineral called aluminous tobermorite. When the Roman mixture was exposed to the relentless pounding of ocean waves, a slow, long-term reaction occurred. Seawater filtering through the concrete actually encouraged the growth of these interlocking, plate-like crystals within the material's structure. Think of it not as a solid block, but as a living rock that constantly reinforces itself. This is the ultimate self-healing material. If a crack begins to form, the infiltrating seawater prompts the formation of new crystals that effectively fill the gap, welding the concrete back together. Modern engineers are only just beginning to create materials with similar properties, using complex chemical additives and industrial processes. The Romans achieved it with a few natural ingredients and empirical knowledge gained through centuries of trial and observation. Yet, even with our advanced analytical tools, we cannot perfectly replicate their concrete. The precise mixing techniques, the exact proportions of volcanic ash from specific Italian deposits, the method of combining the slaked lime with the saltwater, these subtleties have been lost. How did they discover this perfect, resilient formula without an understanding of molecular chemistry? It stands as a monumental achievement of practical engineering, a durable legacy written in stone and seawater that points toward an even more ambitious architectural wonder, one that required moving stones of unimaginable weight. High above the modern city of Cusco, the fortress of Sacsayhuaman presents a wall of sheer impossibility. Its stones are not merely large, they are colossal, some weighing more than 200 tons, the equivalent of a fully loaded blue whale lifted and set into place on a mountain ridge. Yet their immense size is not the true mystery, it is the way they fit together. These giant blocks of irregular, multi-angled limestone are joined so perfectly that their seams have defied erosion, earthquakes, and centuries of scrutiny. You cannot force the edge of a razor blade between them. Each stone is a unique puzzle piece carved with complex, three-dimensional shapes that lock into its neighbors with baffling precision. They feature subtle beveled edges and curious knobs and protrusions that seem to serve no decorative purpose. Scholars like Dr. Jean-Pierre Protzen have spent decades trying to reverse engineer the process, attempting to replicate the work with the tools the Incas are known to have had: simple stone hammers and bronze tools. Yet the experimental results always fall short of the ancient perfection. How do you carve a 20-ton block with such intricate, interlocking contours that it snugly accepts the equally complex face of another stone, all without advanced measuring devices, without even a written language to record the plans? The transportation of these stones is another enigma that defies logic. The quarries were miles away across rugged mountain terrain. The Incas had no wheeled carts, no pulleys, and no strong draft animals like oxen or horses. The conventional theory suggests hundreds of men hauled the stones with ropes, but maneuvering a 200-ton block with such delicate precision up and down steep slopes seems an almost superhuman feat. The engineering, however, goes far beyond mere assembly. This jigsaw puzzle of stone was built to last. Peru is a land of intense seismic activity, and Sacsayhuaman has withstood countless powerful earthquakes. Its secret lies in its brilliant design. The walls are not vertical, they lean inward for stability. More importantly, the complex interlocking joints between the stones act as a dynamic shock absorber. When the ground shakes, the stones do not simply resist the force, they dance. They shift and settle, their unique shapes locking them more tightly together as they move, preventing a catastrophic collapse. This is an advanced application of seismic engineering, a principle modern architects still strive to perfect. The Incas, without the mathematics of structural dynamics, somehow encoded this resilient intelligence directly into the rock itself. They turned immovable weight into flexible, living strength. What lost method of stone whispering, what profound understanding of geometry and force, allowed them to achieve what looks like magic? This mountain fortress stands as a monument to a forgotten school of engineering, one that speaks in the silent, perfect language of stone and prepares us for a journey across the ocean to another structure of impossible precision. The seamless stonework of Sacsayhuaman finds a strange and unsettling echo high on the Bolivian Altiplano. Here, at the ruins of Pumapunku, you do not find walls of colossal boulders, but a scattered field of architectural nightmares. The ground is littered with shattered andesite and granite blocks, but to call them simple stones is a profound understatement. They are geometric nightmares rendered in stone, each one a masterpiece of impossible precision. The edges are not just straight, they are razor-sharp and flawless, forming perfect 90-degree angles that look as if they were cut by a modern diamond saw. The surfaces are so smooth and flat they could be mistaken for polished metal. But the true enigma is the complex, interlocking patterns carved directly into this incredibly hard stone. Deep, perfectly straight channels and notches, T-shaped slots, and symmetrical recesses are cut with a level of accuracy that would demand computer-controlled machinery today. These are not the artistic flourishes of a stone carver, they are the components of a vast, interlocking stone puzzle designed to fit together with zero tolerance. Materials scientist James A. O'Con has studied these ruins extensively, and his conclusions are startling. Working andesite, a stone nearly as hard as granite, to this standard requires tools harder than the material itself. He theorizes the builders must have employed specialized tools, perhaps tipped with diamonds or another superlative abrasive, to achieve such clean, precise cuts. Yet no such tools have ever been found at the site. The very manufacturing process has vanished without a trace. This points to an even more sophisticated concept, one we associate with modern industry, not ancient construction. The blocks of Pumapunku are not unique artworks, they are standardized modular components. Researchers have identified repeating shapes and identical connector pieces, suggesting the builders were using a system of mass production. They could create hundreds of identical, complex stone parts that would snap together to form large, stable structures, much like prefabricated concrete sections in a modern building. What kind of culture, over 1,000 years ago, had developed the concept of an assembly line for stone architecture? How could they ensure such perfect consistency across hundreds of individual blocks without blueprints or precision measuring tools that we can recognize? The silence of Pumapunku is absolute, offering no answers, only the chilling perfection of its shattered components. This manufacturing miracle on a barren plateau immediately raises the next inevitable question. Once you have created these perfect, multi-ton stone blocks, how do you move them? The silent, shattered perfection of Pumapunku leaves us with a haunting question of logistics, a question that finds its echo on the most remote inhabited island on Earth. Easter Island's rolling green hills are guarded by nearly 900 massive stone figures, the Moai, their stern gazes fixed inland. Carved from compressed volcanic ash, these monolithic statues average 13 feet tall and weigh 14 tons, with some unfinished colossus left in the quarry weighing an astonishing 70 tons. For generations, the central mystery was not just how they were carved, but how they were moved miles across the island's rugged landscape. The Rapa Nui people who created them had no wheels, no metal tools, and no large animals to provide draft power. The conventional image of dozens of people dragging them on wooden sledges has been challenged by a compelling and almost surreal alternative. Researchers like Dr. Carl Lipo and Terry Hunt proposed a radical theory that the Moai were not dragged at all but were made to walk. Their experiments showed that with 3 teams of ropes, one anchored to the statue's head and 2 rocking it from side to side, a small group could indeed maneuver a replica Moai in an upright, shuffling gait. This walking method seems to align with local Rapa Nui oral history, which literally states that the statues walked to their platforms, yet this elegant solution only deepens the puzzle. How could such a method be controlled over miles of uneven, often steep terrain without the massive statue tipping over and shattering on the volcanic rock? The risk of catastrophic damage to a figure that might represent a revered ancestor would have been immense. Furthermore, the logistical challenge of coordinating hundreds of people for each statue in a society with limited food and water resources is staggering. The walking theory explains the how but not the overwhelming organizational feat. It also fails to account for the massive stone hats, or pukao, that top some of the statues, each a multi-ton cylinder of red scoria stone that had to be quarried from a different part of the island and then lifted onto the head of a standing statue. The movement of the Moai is a multi-layered engineering puzzle, one of physics, social organization, and raw human ingenuity. It forces us to reconsider what a determined community can achieve with nothing but rope, rhythm, and a shared, monumental vision. This incredible feat of moving giant stones across land pales in comparison to an ancient nation that chose to move them across water, constructing a harbor that should not exist. The challenge of moving the Moai across land is dwarfed by an ambition so grand it borders on the megalomaniacal. In the Bekaa Valley of Lebanon, the foundation of the Roman Temple of Jupiter at Baalbek rests upon 3 blocks of limestone so immense they seem to belong to the realm of myth. Known as the Trilithon, each of these stones stretches over 60 feet in length and weighs approximately 800 tons, the equivalent of 2 fully loaded jumbo jets. They are fitted together with such precision that their seams are virtually invisible, forming a platform that has withstood millennia of earthquakes and wars. Yet the true shock lies not in the temple itself, but in the quarry almost a mile away. There, partially buried in the earth, rests the stone of the pregnant woman, a single block of stone estimated to weigh 1,650 tons. It is the largest known piece of rock ever cut by human hands, a project so audacious it was apparently abandoned before it could even begin its journey. How could any civilization, even the mighty Romans, conceive of moving a small mountain, engineering historian Dr. Daniel Lohman has analyzed the site in minute detail, and his conclusions are humbling. Moving the 800-ton blocks of the trilithon would have required a level of organization and physics that pushes the boundaries of what we believe was possible. The logistics are staggering, demanding the coordinated effort of thousands of workers pulling on ropes in perfect unison, moving the stone on a carefully prepared track of rollers. One misstep, one snapped cable, and the project would have ended in catastrophic failure. The challenge did not end with horizontal movement. These multi-ton megaliths were then lifted over 20 feet into the air and slotted into their exact positions with breathtaking accuracy. This is a lifting enigma that defies conventional explanations of Roman cranes and pulleys, which were simply not designed for such impossible weights. What specialized technology or forgotten knowledge allowed them to achieve this? The silence from the ruins is profound, offering only the sheer, overwhelming presence of the stones themselves. This ancient feat of lifting giants into the sky finds a mysterious parallel in a culture that seemed to defy gravity itself, carving entire cities out of solid rock. The ambition of Baalbek fades before the serene, geometric perfection of the Great Pyramid of Giza. This is not merely a pile of stones, it is a structure of almost impossible mathematical purity. Its four sides are aligned with the four cardinal directions with an accuracy within a fraction of a degree, a feat of surveying so precise it rivals modern engineering. The base of the pyramid forms a near-perfect square, with its sides varying in length by less than the width of your little finger across a distance longer than 2 football fields. This is a margin of error of just 0.05%, a level of exactitude that seems to defy the era of its creation 4,500 years ago. How could a civilization using copper tools and rope achieve such flawless orientation on a scale of millions of tons? The pyramid's builders seem to have possessed a profound understanding of the Earth itself, aligning their colossal monument to true north with an error of only 1/15 of a single degree. This is not a rough approximation, it is a deliberate, masterful act of celestial engineering. Researcher and engineer Christopher Dunn has long argued that this precision points to a level of technological sophistication we are only beginning to appreciate. The pyramid is not just aligned to the north, its entire geometry appears to encode advanced mathematical constants and astronomical relationships, knowledge that should not have existed in the ancient world. The sheer logistics compound the mystery. This perfect form is composed of approximately 2,300,000 individual stone blocks, each one precisely shaped and set into place. Many of these stones weigh 2.5 tons, but the granite beams in the king's chamber weigh up to 80 tons, and they were quarried from a site over 500 miles away. How were these monstrous blocks transported, lifted, and fitted with such hair-thin accuracy? We are asked to believe this was accomplished with ramps, rollers, and copper chisels, yet modern engineers struggle to replicate the feat even with today's machinery. The pyramid stands as a silent rebuke to our assumptions, a mountain of stone whispering of a lost science that perfectly married the earthly and the celestial. This profound connection to the stars hints at a purpose far beyond a simple tomb, pointing toward a deeper, more mysterious relationship with the cosmos. While the pyramids aligned with the heavens, another ancient culture was etching messages so vast they could only be fully comprehended from the sky. Scattered across the arid plains of southern Peru, the Nazca Lines transform 500 square kilometers of desert into a colossal canvas. From the ground, these are little more than shallow grooves in the reddish-brown pebbles, but from above, they explode into a gallery of staggering scale and precision. A hummingbird with wings outstretched, a spider with perfectly articulated legs, a monkey with an intricately coiled tail, all drawn with a single continuous line that never wavers. The straight lines are perhaps the most baffling, running for miles across the uneven desert floor with the unwavering accuracy of a laser beam. How could the Nazca people 2,000 years ago create a 400-meter-wide pelican that is perfectly proportioned, or a 2-mile-long straight line that deviates by no more than a few feet, all while standing at ground level? Archaeologists like Dr. Persis Clarkson have shown that the technique itself was elegantly simple. By driving stakes into the ground and using cords to mark out the designs, a small team could scale up a master pattern. They created the lines by simply removing the dark, sun-baked surface pebbles to reveal the lighter, contrasting soil beneath. Yet this explanation of the method only deepens the mystery of the planning. To execute a design of such immense scale without any visual reference, without being able to step back and check their work, required an unimaginable level of foresight and geometric skill. A single miscalculation in angle over such a distance would result in a figure grotesquely distorted, yet the proportions remain flawless. Many of the longest lines are not random. They point directly to the place on the horizon where the sun or certain stars would rise or set during significant celestial events. This suggests the Nazca possessed not just artistic vision, but a sophisticated understanding of astronomy, encoding their calendar and cosmology into the very earth. The preservation of these fragile scrapings for 2 millennia is another quiet miracle. The desert here is one of the driest places on Earth, but it is not without wind. Yet the unique composition of the soil, a mix of clay and gypsum and a protective layer of sun-hardened pebbles, has created a stable surface that resists erosion. The lines were not just drawn, they were engineered to last, a permanent inscription for an audience they could never see. This raises the most profound question of all. If they themselves could never witness the full glory of their creations, who or what were these earth-spanning drawings truly for? This enigma of desert artistry gives way to a different kind of water-based mystery, one found not on the surface but hidden deep within a flooded cave. Deep beneath the sun-baked plains of Persia lies a hidden river of life, a masterpiece of engineering carved from the dark earth. These are the Qanats, vast underground aqueducts that transformed barren deserts into blooming gardens. For over 2,000 years, this network of tunnels silently channeled water from mountain aquifers to arid valleys, sustaining entire civilizations where none should have thrived. The sheer scale is staggering, with some Qanats stretching for more than 30 miles through solid rock and soil. But the true genius lies not in their length, but in their impossible precision. To keep water flowing at a steady, gentle pace without washing the tunnels away, Persian engineers had to maintain a perfect downhill gradient. We are not talking about a steep slope, but an almost imperceptible decline of just 1 to 0.3%. That is a drop of only 1 foot for every 1,000 feet of tunnel. Achieving this with nothing but hand tools, muscle, and intuition seems beyond belief. How could they possibly calculate such a minute slope across miles of pitch-black, winding subterranean passage? The answer was as elegant as it was dangerous. Teams of specialized workers known as mukanis would begin by sinking a series of vertical shafts, sometimes hundreds of them, down to the water table at the foot of a mountain. From the bottom of the farthest shaft, they would then begin digging the main tunnel backward toward the mother well. These vertical shafts, spaced like clockwork every 100 feet or so, were far more than just construction holes. They provided crucial ventilation for the diggers below and served as permanent maintenance access points for centuries to come. This was not just digging, it was a profound application of hydrology, geology, and physics. Historian Dr. Dale Lightfoot has mapped countless ancient Qanats, and his research reveals a system of breathtaking foresight. The builders had to possess an innate understanding of the water table, the composition of the soil, and the precise mechanics of water flow, all without a single modern instrument. They used simple tools like weighted strings and sighting poles to maintain their line and grade, a testament to human skill pushed to its absolute limit. The result was a self-sustaining hydraulic system that required no pumps or external power, delivering cool, clean water for drinking and irrigation while minimizing evaporation in the brutal desert heat. This lost art of tapping the Earth's hidden veins allowed cities to flourish in the most unforgiving landscapes, creating oases of life where only sand should exist. It stands as one of history's most enduring and practical engineering marvels, a quiet, flowing mystery that humbly precedes the grandeur of our next architectural puzzle. Deep beneath the rolling hills of Cappadocia lies a hidden world of astonishing complexity. The Derinkuyu underground city is an 18-level labyrinth carved directly into the soft volcanic rock, a shelter so vast it could house 20,000 people. Yet the true marvel of this buried metropolis is not its scale, but the very air its inhabitants breathed. At depths reaching 280 feet, how could such a dense population survive without suffocating? The answer lies in a masterpiece of passive engineering, a network of 52 ventilation shafts that acted as the city's hidden lungs. These were not simple holes. Some shafts plunged directly to the surface, drawing in fresh, cool air, while others were ingeniously connected to hidden openings and water wells, creating a continuous, natural draft. This was a complete circulatory system for a stone city, all functioning without a single moving part. Engineering analysis by researchers like Dr. Özkan Yilmaz reveals the terrifying brilliance behind this design. The placement, diameter, and depth of the shafts were not random. They followed principles of fluid dynamics, using differences in air temperature and pressure to create a constant, gentle flow. The warm, stale air from the crowded living areas would rise and escape through the higher shafts, while cooler, denser air was drawn in from the surface below, creating a self-regulating cycle. This was not just ventilation, it was a form of underground climate control. The system maintained a stable, comfortable temperature year-round, protected from the scorching summers and freezing winters above, while ensuring the air remained fresh and free of dangerous levels of carbon dioxide and moisture. How could builders nearly 3,000 years ago possess such an intuitive grasp of aerodynamics and thermodynamics? They left no equations, no written theories, only the perfect, functioning proof carved into the earth itself. This subterranean sanctuary, with its silent, breathable depths, represents an environmental control system that rivals the most thoughtful modern passive designs. It forces us to reconsider what ancient societies understood about their world, turning the very earth into a life-sustaining machine, and raising the question of what other buried wonders were created with this same invisible intelligence. While ancient cultures mastered the art of surviving earthquakes, one civilization attempted the impossible, predicting them. In the year 132, during the Han Dynasty, the brilliant astronomer and engineer Zhang Heng unveiled a device that seemed to defy the very nature of reality. It was a bronze urn, ornate and massive, encircled by 8 dragons, each one poised with a bronze ball held loosely in its jaws. Below each dragon sat a corresponding bronze frog, its mouth open wide in anticipation. This was the world's first seismoscope, and it did not merely sense local tremors, it detected earthquakes from hundreds of miles away. According to historical records, when a quake struck far beyond the horizon, the internal mechanism would trigger one of the dragons. It would release its ball, which would clatter into the frog's mouth below, not only signaling that an earthquake had occurred but pointing unerringly in its direction. The court annals tell of an instance where a dragon dropped its ball, yet no one in the capital felt a thing. Days later, a messenger arrived from a remote province, reporting a massive earthquake in the exact direction the device had indicated. The precision was unnerving. How could a 2,000-year-old vessel sense ground vibrations so faint they were completely imperceptible to every person in the city? Modern scientists have been trying to solve that puzzle for decades. Physicists like Dr. Wang Deyu have proposed that the secret lay in a sophisticated internal mechanism, likely an inverted pendulum. Think of a tall, heavy mass delicately balanced upside down inside the vessel. The slightest horizontal motion from a distant seismic wave would disturb this unstable equilibrium, causing the pendulum to swing and trigger a lever system that released one specific bronze ball. This principle of unstable equilibrium for detection was not understood in the West until the 19th century. Yet every attempt to build a fully functional replica based on this idea has fallen short of the sensitivity described in the ancient text. Our modern versions simply cannot detect the incredibly subtle, long-period waves of a far-off quake with the same accuracy. Something is missing from our understanding, perhaps a lost detail about the internal construction, the specific type of bronze used, or the exact arrangement of the levers. Zhang Heng's device represents a pinnacle of instrumental intuition, a machine that could feel the heartbeat of the planet itself. It stands as a ghost of a different kind of knowledge, one that listened to the Earth's whispers and provided a warning that could save thousands of lives. This ancient quest to predict the unpredictable leads us to another civilization that mastered a different, equally vital form of environmental control. The ability to predict an earthquake is one thing, but to command an unquenchable flame is an entirely different kind of power. For the Byzantine Empire, that power was Greek fire, a weapon so terrifying it could decide the fate of empires from the deck of a single ship. Imagine a liquid fire that clung to everything it touched, that roared into an inferno upon contact with water, and that no amount of water could possibly extinguish. This was not a myth, it was the secret weapon that protected Constantinople for over 7 centuries, a chemical ghost that modern science still cannot fully resurrect. The strategic advantage was absolute. Byzantine Droman warships were fitted with pressurized bronze siphons, monstrous tubes that could project this liquid nightmare in a continuous, roaring stream onto enemy vessels. In naval combat, where wood and water were the only realities, an enemy ship suddenly coated in a fire that water only fed was a sight of pure, undiluted horror. The formula for this incendiary substance was the most closely guarded state secret in the world, known only to a select few, possibly even the emperor and a single family of chemists. Its composition was so protected that when the empire finally fell, the knowledge vanished with it. For decades, historians and chemists like Dr. John Haldon have played a dangerous game of historical detective, piecing together clues from vague and often contradictory ancient texts. The most plausible theories suggest a volatile cocktail of crude petroleum, perhaps from surface seepages around the Black Sea, mixed with other mysterious ingredients. Some propose quicklime, which ignites upon contact with water, or niter, a chemical that would have provided its own oxygen supply, allowing it to burn even underwater. Yet every modern attempt to recreate Greek fire has failed to capture its legendary properties. Our best imitations may burn, but they do not burst into flame upon hitting the sea, nor do they resist water with the same tenacious fury described by panicked Arab historians. The secret likely lies not in a single ingredient, but in a precise multi-stage manufacturing process, a specific type of crude oil with unique chemical properties, or an additive whose identity is forever lost. The delivery system itself was a marvel of mechanical engineering that would not be seen again until the Renaissance. The bronze siphons were not simple pots of burning oil. They were complex pumps and pressurized tanks that allowed the operator to aim and project the stream with the force of a modern flamethrower. How did Byzantine engineers, without modern metallurgy or pressure vessel science, construct a device that could safely contain and eject such a volatile substance? This was not just a chemical weapon, it was an integrated system of chemistry and mechanical engineering, a terrifying synergy of knowledge that gave a single civilization dominance over the seas. The ghost of Greek fire is a dual mystery, a lost formula and a forgotten machine, a blazing testament to how one brilliant, guarded secret can shield an empire for hundreds of years, only to vanish without a trace. That same Byzantine fire that guarded an empire was a known, tangible terror, but one book from the same era holds a horror of pure, impenetrable mystery. Locked away in the Baghdad Library at Yale University is the Voynich Manuscript, a 240-page codex written entirely in a script that has defied every attempt at translation for over a century. This is not merely a book of unknown words, it is a gallery of impossible engineering. Its pages are filled with intricate, technical drawings of systems that should not exist, rendered with a draftsman's precision. You see sprawling networks of pipes and vessels that look like sophisticated hydraulic pumps or perhaps a plant circulatory system, all drawn with the clarity of a mechanical diagram. Other pages show complex astronomical devices with interlocking gears and celestial charts that track unknown stars. There are even detailed illustrations of biological mechanisms, showing what appears to be cellular processes or organic plumbing, a fusion of biology and engineering that feels centuries ahead of its time. Cryptographers like Dr. Stephen Bax have managed to tentatively identify a handful of plant names based on the illustrations, proving the text is not entirely random. Yet the purpose and function of the bizarre devices themselves remain a complete enigma. They possess an internal logic, a sense of being functional blueprints for something real, but they do not correspond to any known technology from the 15th century or any era that followed. The precision of these technical drawings is the most compelling clue, suggesting the author was not a fantasist but someone with specific, perhaps even advanced, engineering knowledge. Was this a secret inventor documenting revolutionary ideas in a coded language to protect his work? Or could it be the work of a scholar attempting to reconstruct lost knowledge from a much older, now vanished source? The manuscript's cryptographic defense is as perfect as its engineering. Statistical analysis shows its language has a complex structure, with word patterns that mimic natural language, ruling out a simple, meaningless cipher. It is a locked door with no keyhole, a detailed instruction manual for machines we cannot recognize, written in a language we cannot read. This cryptographic ghost, a book of tangible blueprints for the intangible, shifts our gaze from the mysteries of our own world to an object that literally fell from the stars. Across the English Channel, the French countryside holds a different kind of mystery, one of vast, open-air geometry. The Carnac stone alignments are a staggering sight, a forest of granite standing stones arranged in rows so long and straight they seem to defy the natural chaos of the land. Nearly 3,000 of these megaliths were raised over a 1,000-year period, beginning around 4,500 years before the Common Era. They march across the fields in 13 major rows, some lines stretching for over a mile with a relentless, almost mechanical straightness. From ground level, the scale is overwhelming, but from above, the pattern becomes hauntingly deliberate. This was not a random collection of stones. It was a colossal project of land surveying executed with Neolithic tools. The question of how they achieved such precision without a written language or advanced measuring devices has led researchers like archaeoastronomer Dr. Alexander Thom to propose a radical idea. He spent decades meticulously surveying megalithic sites across Europe, and his work at Carnac suggests the builders possessed a sophisticated, standardized unit of measurement, a megalithic yard, and a complex understanding of geometry. Certain alignments at Carnac appear to lock onto key points of the lunar cycle, marking the moon's extreme rising and setting positions in an 18.6-year cycle. This was not simple sun worship. It was a precise, long-term astronomical observatory carved into the landscape itself. The engineering effort behind this is as immense as the astronomical knowledge. These are not small rocks. Many of the stones weigh tens of tons, and they were hauled from quarries miles away. The sheer coordination required to transport and erect them, to set them in lines that remain straight across hills and valleys, speaks of a highly organized society with a single, powerful vision. What drove these Neolithic farmers to dedicate centuries to this back-breaking labor? Was it a celestial calendar, a sacred pathway, or a territorial marker of a forgotten kingdom? The stones stand in silent, perfect rows, a monument to a lost purpose that challenges our perception of prehistoric society as simple or unsophisticated. This incredible feat of organizing thousands of stones across the land finds a strange and inverted parallel in a single, impossible block of stone that was never meant to move. Perched 75 meters high on a sheer cliff face, the hanging temple of Mount Heng seems to float against the rock, a collection of pavilions and walkways that have defied gravity for over 1,500 years. This is not a structure built upon the mountain, but one woven directly into its fabric. From a distance, it looks like a delicate wooden model glued to the vertical stone, a feat that appears more like magic than architecture. The secret to its defiance lies in a system of deceptively simple oak crossbeams. Builders during the northern Moai dynasty chiseled deep holes into the solid cliff and hammered these sturdy beams into the living rock. The wooden halls and corridors are then cantilevered out from this foundational skeleton, creating a structure that is partly supported by the beams and partly anchored directly to the mountain itself. In some rooms, the floor you walk on is not wood at all, but the smoothed surface of the cliff, making the temple an inseparable part of the mountain. Structural engineer Dr. Lai Xiaodong has studied the temple's resilience, noting how its design is a masterclass in passive engineering. The entire complex is nestled beneath a prominent overhang, which acts as a giant natural roof, shielding the wooden structure from the eroding forces of rain and snow. More importantly, this strategic placement protects it from the powerful, gusting winds that whip through the valley, forces that would easily tear a freestanding building of this height to pieces. The location itself is a calculated defense against earthquakes. By being fused with the mountain, the temple moves with the seismic waves rather than resisting them, its flexible wooden joints and deep rock anchors allowing it to sway and settle without collapsing. The construction process, however, remains a terrifying puzzle. How did 5th century workers without harnesses or cranes even begin this project? They would have had to dangle from ropes, chiseling the initial holes and inserting the first beams while suspended above a fatal drop. The coordination required to lift heavy timber and precisely fit complex joinery in such a precarious space speaks of an almost unimaginable bravery and skill. How did they calculate the load-bearing capacity of the rock or the stress limits of their oak beams without the mathematics of modern engineering? They relied on an empirical wisdom passed down through generations, an intuitive understanding of materials and forces that allowed them to create a sanctuary that hangs between heaven and earth, a gravity-defying miracle that points toward another culture that carved its wonders directly into the Earth's heart. Hidden within the lush jungles of Java, Borobudur Temple rises as a massive, silent mountain of stone. This 9th-century Buddhist monument is the largest of its kind in the world, but its true secret is not in its size, but in the invisible mathematical code woven into its every dimension. The structure is a perfect mandala in plan, a series of square and circular terraces that guide pilgrims on a symbolic journey from the earthly realm to enlightenment. Yet this sacred geometry is also a display of breathtakingly advanced mathematics. The ratios between the different levels, the precise heights and widths of the galleries, all conform to the same mathematical constants that would later define Islamic architecture and European cathedrals. The builders used a system of measurement based on the human body, the tala, but the resulting proportions achieve a level of harmonic perfection that feels less like measurement and more like music frozen in stone. Archaeologist Dr. John Mixick has spent decades mapping the temple's every contour, and his research reveals an even deeper layer of intent. The dimensions of the entire structure appear to be a scaled representation of astronomical cycles. The total length of the monument's base, for instance, correlates precisely with the number of days between certain lunar phases, while the number of stupas and statues corresponds to specific cosmic intervals. This is architecture as a cosmic calendar, a stone embodiment of the universe's rhythms. The organizational feat behind this mathematical marvel is just as staggering. The temple is composed of 55,000 square meters of volcanic andesite stone, all cut into over 2 million individual blocks. These blocks were assembled without any mortar, fitting together through pure, precise joinery to create 2,672 intricately carved relief panels and 504 statues of the Buddha. The reliefs tell a continuous story spanning nearly 2 miles in length, a narrative carved with such consistency it suggests a single, overarching artistic vision executed over generations. How did a society with no surviving evidence of a written mathematical tradition plan and execute a project of such staggering complexity? There were no calculators, no detailed blueprints on parchment, no formalized system of geometry that we can recognize. The knowledge must have been an oral tradition, a set of rules and ratios passed down from master builders to apprentices, a practical geometry encoded in ritual and practice. This living knowledge, once lost, could not be recovered. Borobudur stands as a monument to a sophisticated engineering consciousness that we can only partially decipher, a mathematical ghost that silently questions the timeline of human discovery and leads us to another structure where form and function merge in a seemingly impossible balance. The silent mathematical perfection of Borobudur finds a stunning parallel in the highlands of Mexico. Teotihuacan was a metropolis of staggering order, a city built with a geometric vision that humbles modern urban planning. Long before the Aztecs named it the City of the Gods, its architects laid out a master plan on a scale of 8 square miles, a grid so precise it seems drawn by a celestial hand. The central artery, the Street of the Dead, does not run north-south as one might expect. Instead, it is aligned precisely 15.5 degrees east of true north. This was not a simple surveying error, it was a deliberate act. This specific angle corresponds to key astronomical events, including the setting of the Pleiades star cluster, a moment of profound ritual significance for the Teotihuacanos. The entire city was oriented to the cosmos, making it a giant astronomical instrument built of stone and earth. Anthropologist Dr. Saburo Sugiyama has spent decades unearthing the city's hidden logic. His research reveals that the placement of the 3 great structures, the Pyramid of the Sun, the Pyramid of the Moon, and the Temple of Quetzalcoatl, forms a perfect right-angled triangle. The distances between them are not random. They encode mathematical ratios found in nature, including a close approximation of the constant pi. This suggests the builders possessed a sophisticated understanding of geometry that allowed them to translate abstract mathematical concepts into a colossal urban landscape. How could they achieve such accuracy over such vast distances without theodolites or modern measuring tools? The entire city functioned as a single, integrated machine. Beyond the pyramids, a complex water management system of carved channels and underground drains controlled rainfall and provided for a population that may have reached 100,000 people. This was urban planning on a scale and with a level of integration that would not be seen in Europe for over a millennium. The sheer coordination of labor is almost unbelievable, demanding that generations of workers adhere to a single, unwavering master plan. Who were the master architects behind this project, and what system of knowledge allowed them to execute a vision of such flawless, enduring precision? The city's silent, geometric streets point toward another culture that also mastered impossible angles, but on the surface of a single, mystifying stone. The silent, geometric streets of Teotihuacan speak of a civilization in perfect control of its urban plan, but on the islands of Malta, the land itself is scarred by a purpose that has been completely erased. Etched into the limestone bedrock are the Maltese Ruts, a sprawling web of parallel grooves that have baffled archaeologists for generations. These are not random fissures in the stone. They form complex networks of tracks, some running arrows straight for hundreds of meters across the landscape, while others converge into intricate intersections that look like prehistoric railway switches. The tracks are worn to a remarkably consistent depth and width, suggesting they were not carved by hand, but created by the relentless passage of something heavy, over and over again for centuries. Geological analysis by researchers like Dr. Gordon E. Weston confirms they are thousands of years old, dating back at least 7,000 years. This places their creation in a time before the pyramids of Giza were even a concept, long before the wheel was in common use in the Mediterranean. The true engineering puzzle lies in their precision. The parallel tracks maintain a consistent spacing from each other, a fixed gauge, regardless of the terrain they cross. They plunge down steep slopes cut across rocky plateaus and even disappear straight into the Mediterranean Sea, only to reappear on the opposite shore. This unwavering parallelism is the key clue, and it shatters simple explanations. These were not formed by sledges dragging irregular loads. A sledge would wobble and sway, creating meandering, uneven grooves. The ruts indicate a vehicle with a fixed axle, a stable platform that kept the wheels, or whatever was creating the grooves, locked into a precise, unchanging distance from one another. What kind of vehicle possessed this sophisticated guidance system? What was it carrying that required such an immense, island-wide network of permanent tracks? The most logical theory is that they were used to transport massive blocks of stone from inland quarries to coastal temples, but this raises more questions than it answers. Why create such deep, permanent grooves in solid rock instead of using temporary roads or paths? The effort to create the tracks in the first place would have been monumental, implying they were intended for thousands of journeys over countless generations. The grooves are also often too narrow and too deep for any practical cart with wooden wheels we can envision. Could the vehicle have been something entirely different, a type of rolling conveyance or a guided sled system whose design is now utterly lost to us? The ruts are a fossilized imprint of an entire transportation system, a ghost of logistics on an industrial scale, yet we cannot identify the machine that left its mark. This ancient mystery of guided movement on land finds a strange and beautiful parallel in a different kind of machine, one designed not to traverse the earth but to map the heavens. Standing in the heart of Delhi for 16 centuries, a 7-meter-tall iron pillar defies one of nature's most relentless laws. While modern steel bridges and cars require constant repainting and maintenance to fight a losing battle against rust, this 6-ton colossus has stood completely exposed to monsoon rains and tropical humidity without succumbing to the reddish-brown decay. Its surface is smooth and dark, bearing only a fine, stable patina that actually protects the metal beneath. This is the Iron Pillar of Delhi, and its secret is not in its composition alone, but in a forgotten art of manipulation at the atomic level. Modern metallurgists like Dr. R. Balasubramaniam have used advanced spectroscopic analysis to peer into the pillar's crystalline heart, and what they found was a beautiful accident of ancient high-tech craftsmanship. The key is a microscopically thin, protective film that coats the entire pillar, a compound called mesawite. This layer is a specific blend of iron, oxygen, and hydrogen that forms an invisible, self-repairing barrier, actively preventing oxygen from the air and water from penetrating deeper to cause destructive rust. How did ancient Indian blacksmiths, working over 1,600 years ago, create such a sophisticated passive shield? The answer lies in two critical factors they controlled without even knowing it. First, the iron used had an unusually high phosphorus content, a result of the unique iron ore and the specific charcoal-based smelting process used at the time. Second, and most crucially, was the manufacturing technique itself. The pillar was not cast as a single piece. It was painstakingly built up by heating and hammer, welding hundreds of individual iron discs together in a massive, sustained forge welding operation. This intense, rhythmic hammering while the metal was hot, a process that would have involved teams of artisans working in concert, encouraged the phosphorus to migrate to the surface. There, it interacted with the atmosphere to catalyze the formation of that perfect, protective mesawite layer. It was a perfect storm of material science and artisanal skill, a recipe that was likely never fully understood even by its creators. Modern industry struggles to replicate this effect because our processes are too pure and too efficient. We remove phosphorus as an impurity because it can make steel brittle, and we use industrial methods that do not create the same surface conditions. The ancient method was a happy, brilliant convergence of impure materials and a specific, labor-intensive technique, knowledge that was likely passed down through guilds and was lost when that unbroken chain was severed. The pillar itself holds another clue to this lost knowledge in the form of a Sanskrit inscription, which indicates it was originally erected elsewhere, perhaps to commemorate a great king, and was only moved to Delhi centuries later. This raises a secondary engineering nightmare. How do you transport a 6-ton, 23-foot-tall solid iron obelisk across the rugged Indian landscape without the benefit of modern trucks and cranes? The logistical feat is a ghost of its own, a silent testament to a civilization that had mastered both the microstructure of metal and the macro problem of moving it. This enduring monument, a sentinel of rust-resistant iron, stands as a direct challenge to our assumptions of progress, proving that some forgotten solutions were, in their own way, perfectly advanced. Deep within the river deltas of Costa Rica, the jungle hides a collection of perfect forms. Scattered across the landscape are hundreds of stone spheres, some small enough to hold in your hand, others standing taller than a person. Carved from a single, incredibly hard rock called gabbro, these spheres are not merely round, they are geometrically precise to a degree that seems to defy their ancient origins. Many display a sphericity with surface variations of less than 5 millimeters, a level of perfection you would expect from a modern machine shop, not from a pre-Columbian society working with stone hammers. Archaeologists like Dr. John W. Hoops have studied these artifacts for decades, and the accepted method of creation is deceptively simple. The artisans likely used a technique called pecking and grinding, repeatedly striking the raw stone with other hard rocks to rough out the shape, then painstakingly grinding it with sand and water to achieve that breathtaking smoothness. Yet knowing the basic method does not solve the core mystery. How did they achieve such mathematical perfection without any known measuring devices, without calipers or blueprints? How could they look at a multi-ton block of stone and see the perfect sphere hidden within, then remove just enough material to set it free? The process would have required not just skill, but a profound, intuitive grasp of geometry, an ability to judge symmetry and curvature by eye and by hand alone. This artistic and engineering feat is only half the puzzle. Once created, these massive stone balls, some weighing 16 tons, had to be moved. The quarries were often miles from their final resting places, through dense jungle and across rugged terrain. How were these colossal, perfectly smooth orbs transported without them sinking into the soft earth or cracking under their own immense weight? The logistics are a silent nightmare of ropes, ramps, and coordinated human effort, a system of movement that has left no trace behind. Their purpose is the final, frustrating layer of the enigma. Were they astronomical markers aligning with celestial bodies, status symbols for powerful chiefs, arranged in patterns outside their homes, or perhaps they held a deeper, ritualistic meaning, representing the sun, the moon, or the very concept of perfection in a world of chaos? Without a written record from the people who made them, the spheres offer no answers. They simply sit, silent and implacable, their smooth surfaces reflecting centuries of unanswered questions. This spherical mystery, a testament to lost geometric genius, rolls our attention toward a final, chilling puzzle, one that emerges not from the jungle, but from the icy depths of the Arctic Ocean. Etched into the stone walls of the Hathor Temple at Dendera is a carving that refuses to fit neatly into history. Within a darkened chamber, a massive, pear-shaped object stands upright, and inside it, a snake stretches the full length of its body, its head pointing toward a box held by a priest. A cable seems to run from the box into the base of the bulb, while a two-armed pillar, looking remarkably like a modern insulator, supports the entire assembly. To many, this is not a mythological scene, it is a technical diagram, the Dendera light bulb. The interpretation is startlingly literal. The bulb is the glass enclosure, the snake is the glowing filament, the cable is an electrical wire, and the box is the power source, perhaps a version of the Baghdad Battery. Proponents of this theory point to a practical problem that such a device would have solved: the complete absence of soot in deep, windowless tombs and subterranean passages like those found within the Great Pyramid. How did ancient artists paint these intricate murals in total darkness without filling the sealed chambers with smoke from countless oil lamps or torches? An electric light would provide the perfect, clean solution. Mainstream Egyptology, however, offers a different, deeply symbolic reading. Scholars like Dr. F.D. Friedman explain that the scene is a well-known representation of a foundational Egyptian creation myth. The bulb is not a bulb at all, but the womb of the sky goddess Nut, from which the sun god is born each morning. The snake is the deity Harsomptus, a manifestation of the sun itself, emerging from the lotus flower which symbolizes creation. The pillar is the Jed, a symbol of stability, and the entire tableau depicts the cosmic cycle of rebirth, not a technological invention. This orthodox view is backed by the context of the surrounding carvings, which are filled with similar gods and religious iconography. Yet the resemblance remains uncanny. a persistent ghost of anachronism. The debate ultimately hinges on perspective. Are we looking at a sophisticated understanding of electrical principles cleverly disguised within religious symbology, a way to encode and preserve dangerous knowledge? Or is this a classic case of pareidolia, where our modern minds see a familiar object in an ancient and entirely sacred image? The carving offers no definitive answers, only a silent, stone question mark that illuminates the vast gulf between our world and theirs. It brightens the path toward a final, unifying question, a puzzle composed of all the others. These 23 engineering puzzles form a scattered constellation across our planet's past, separated by oceans and by thousands of years. Yet when you step back, a startling pattern emerges from the noise. From the self-healing Roman concrete to the rust-resistant iron of Delhi, we see a recurring, sophisticated grasp of materials science. From the celestial alignments of the Great Pyramid to the mathematical harmonies of Borobudur, we witness an advanced application of geometry and astronomy. These are not isolated flukes, but distinct echoes of a shared human genius. In many specific applications, from the earthquake-resistant walls of Sacsayhuaman to the passive ventilation of Derinkuyu, their solutions rival or even surpass what our own modern engineering can achieve with the same constraints. Historian of technology Dr. James E. McClellan argues that our biggest mistake may be underestimating the innovative capacity of these societies. The archaeological record is fragmentary, built from what accidentally survived the ravages of time, meaning we are likely seeing only a tiny fraction of their true technological landscape. This leads to the most profound pattern of all, the ghost that haunts all these marvels: technological regression. Again and again, we find a brilliant peak of knowledge, like the Antikythera Mechanism, followed by a silence lasting a millennium or more. The intricate gearwork vanishes only to be painfully reinvented during the Renaissance. The recipe for indestructible Roman concrete is lost, forcing us to spend centuries relearning its principles. This is not a smooth, linear climb of progress, but a jagged line with deep, mysterious valleys. What does this repeated cycle of discovery and amnesia tell us? It suggests that knowledge is not a permanent possession, but a fragile flame. It can be extinguished by social collapse, by the loss of a single guild of master builders, or by a shift in priorities that deems a technology no longer valuable. If so many advanced techniques could be forgotten, what does that imply about the permanence of our own technological civilization? The collective testimony of these 23 puzzles forces us to abandon a simple story of human advancement and confront a much more complex and humbling truth. These scattered marvels form a haunting testament to a recurring pattern, not of steady progress, but of brilliant flashes of genius followed by long silences. The intricate gearwork of the Antikythera Mechanism vanishes for over 1,000 years. The recipe for Roman concrete that grows stronger in seawater is lost to the ashes of the fallen empire. This persistent cycle of discovery and profound amnesia forces us to reconsider the very nature of human advancement. Our timeline is not a smooth, upward curve, but a jagged line with deep, mysterious valleys. As the engineer Henry Petrosky once observed, the most amazing achievements are those that defy our established understanding of the possible. These 23 puzzles do exactly that, challenging the backbone of our historical narrative. They whisper that knowledge is not a permanent possession, but a fragile flame that can be extinguished by social collapse, by the loss of a single guild of artisans, or by a simple shift in a civilization's priorities. If so many sophisticated techniques could be forgotten, what does that imply about the permanence of our own technological world? We are left with a humbling and awe-inspiring truth that the past is not a simple prologue. but a repository of wonders we are still learning to see. Which of these engineering enigmas captured your imagination the most? Let us know in the comments and subscribe for more journeys into history's greatest mysteries. The conversation with our past is far from over, and its next revelation could be waiting just beneath the next layer of sand, stone, or silent, forgotten code.